Greetings everyone. Today we're going to discuss about heuristic search methods, stochastic and genetic algorithms. I am going to tackle about heuristic search methods. What is a heuristic search? A heuristic is a technique to solve a problem faster than classic methods or to find an approximate solution when classic methods cannot. This is a kind of a shortcut as we often trade one of the optimality, completeness, accuracy, or precision for speed. A heuristic or a heuristic function takes a look at search algorithms. At each branching step, it evaluates the available information and makes a decision on which branch to follow. So why do we need heuristics? One reason is to produce in a reasonable amount of time a solution that is good enough for the problem in question. It doesn't have to be the best, an approximate solution will do since this is fast enough. Most problems are exponential. Heuristic search let us reduce this to be a rather polynomial number. We use this in artificial intelligence because we can put it to use in situations where we can't find known algorithms. We can say heuristic techniques are weak methods because they are vulnerable to combinatorial explosion. Heuristic search techniques in artificial intelligence. Briefly, we can taxonomize such techniques of heuristic into two categories. A. Direct heuristic search techniques in artificial intelligence. Other names for this are blind search, uninformed search, and blind control strategy. These aren't always possible since they demand much time or memory. They search the entire state space for a solution and use an arbitrary ordering of operations. B. Weak heuristic search techniques in artificial intelligence. Other names for this are informed search, heuristic search, and heuristic control strategy. These are the effective and applied correctly to the right types of tasks and usually demand domain-specific information. We need this extra information to compute preference among child nodes to explore and expand. Each node has a heuristic function associated with it. Heuristic search techniques in artificial intelligence. Before we move on to describe a certain technique, let's first take a look at the ones we generally observe. Below, we name a few. Best first search, A search, bidirectional search, taboo search, beam search, simulated annealing, hill climbing, constraint satisfaction problems. So next to discuss about stochastic hill climbing methods by Bernaldez.
So good day everyone. So before I tackle about stochastic algorithm, I will discuss first the hill climbing because since ang stochastic algorithm is part sa hill climbing. So hill climbing in artificial intelligence. This is a heuristic for optimizing problems mathematically. We need to choose values from the input to maximize or minimize a real function. It is okay if the solution is at the global optimal maximum. So one such example of hill climbing will be the widely discussed traveling salesman problem, one where we must minimize the distance he travels. So types of hill climbing in artificial intelligence. So there are three types of hill climbing. So the first one is simple hill climbing. The second is steepest ascent hill climbing. And lastly is the stochastic hill climbing. Simple hill climbing, this examines one neighboring node at a time and selects the first one that optimizes the current cost to be the next node. Steepest is this examines all neighboring nodes and selects the one closest to the solution state. stochastic hill climbing, this selects a neighboring node at random and decides whether to move to it or examine another. So maghatag ko og example in the next few slides para masabtan ni siya, specifically sa stochastic hill climbing. So features of hill climbing algorithm. So there are three features of hill climbing. First one is generate and test alternative. So hill climbing algorithm is a variation of generate and test algorithm which generates alternative courses of actions to see if they will solve the problem. Second is greedy approach. Hill climbing algorithm will always move in a direction which will give the best outcome. This is done to optimize cost. So the third one is no backtracking. The algorithm cannot go back to its old path. It does not remember its previous state and cannot backtrack. State and space diagram is a representation of the hill climbing algorithm which shows the various states of the algorithm and their corresponding cost function values. So there are 5 states, and these are global maxima, local maxima, plateau, shoulder, and current state. So global maxima represents the highest peak in the entire state and space diagram. This region has the best cost function in the entire area. So one in global maximum, and the local maximum is the highest peak in its neighborhood, but there exists a better state, which is the global maxima. It has the best cost function in its area. So ang global maxima is the entire area, ang local is in its area lang. So ang plateau is a flat region in space. The neighboring points in a plateau have the same cost function. Next is shoulder. Is a plateau which has an upwards edge. It curves up a little bit further on and leads to a higher elevation. And lastly is the current state. Is the region of the state and space diagram where we are present during the search. So problems in different regions in hill climbing. Hill climbing cannot reach the optimal or best state, which is the global maximum, if it enters any of the following regions. So first is ang sa local maximum. At a local maximum, all neighboring states have a values which is worse than the current state. Since hill climbing uses a greedy approach, it will not move to the worst state and terminate itself. The process will end even though a better solution may exist. So, balik tayo sa last slide. So, sa local maximum daw is og mo-reach ka sa local maximum, i-assume na sa algorithm nga mao na ang pinaka-highest nga peak, which is dili kay naa pa man si global maximum. So how to overcome it is utilize backtracking technique. Maintain a list of visited states. If the search reaches an undesirable state, it can backtrack to the previous configuration and explore a new path. So magamit daw og backtracking technique. So the second problem sa hill climbing is ang plateau. On plateau, all neighbors have same value. Hence, it is not possible to select the best direction. Sa kaysa plateau is so mauni ang plateau is ang both niya is mo adto man ka sa downwards. So ang algorithm is mangita man siya og ganang mas better, which is ang higher. So wala man siya higher, mao nang appeal siya sa problems sa hill climbing. So how to overcome it is make a big jump. Randomly select a state far away from the current state. Chances are that we will land at a non-plateau region. So the third one is ridge. Any point on a ridge can look like peak because movement in all possible directions is downward. Hence, the algorithm stops when it reaches this state. To overcome ridge in this kind of obstacle, use 2 or more rules before testing. It implies moving in several directions at once. So, stochastic hill climbing. This algorithm does not examine its neighbors before moving. It selects a random neighbor and decides whether to update it as a current state or not. So, mao ni ang algorithm sa stochastic hill climbing. So sa atong example diri is 3 data. So ang atong initial state is the letter A, then atong goal state is the letter K. So sa stochastic hill climbing, iyahan daw i-choose randomly between the neighboring state as long as mas better siya sa initial state. So sa atong case si A, which is kaning naay value nga 37. So mag-choose siya randomly sa iyahang neighboring states or like the child nodes between 39, 40, 41. Since ang kaning nga values 39, 40, 41 is better than 37, so mag-choose siya randomly nilang tulo. So for example si D, nag-choose siya randomly ni D. So sunod is mo ni ang figure para makasabot mo. Then after nag-choose siya ni D is na mag-choose siya ni I o ni J. So since 44 o si 46 is better ni 41, which is atong initial state na, so mag-choose siya ni I or J. Pwede ra siya mag-choose randomly. So kintahay nag-choose siya ni J is 46. Then naa pa man si J i-compare na pod, which is si K. Then ang 50 nga value is kanang better ni 46, so maka-reach ta sa goal state. Mao na ang stochastic hill climbing. Pero ang downside sa stochastic hill climbing is if mo-choose siya ani, since kay balik ta ani si A initial state, since kani silang tulo si B, C ug D 39, 40, 41, iyang values is better ni 37. What if randomly ni choose siya ni 40, which is si C? Then sunod ni C, mao na po na initial state nato si C, mag-choose na po siya between ni letter G o H, which is 47 o 49 nga values nga better po, mas higher pa ni 40. So pwede siya mag-choose between ni G or H. Sa atong case kintahay si G iyang gipili. So since ang goal state kay naa man diri si K niya si G ang last nga initial state, mao na i-assume sa algorithm nga best optimal solution, iyang i-assume nga mao ni ang pinaka highest peak, which is dili. So mao na ang downside sa stochastic hill climbing.
Good day everyone. So now I will be talking about genetic algorithm. So explained by an example missionaries. So there is a problem popularly known as a knapsack problem. As you can see guys. Okay, I'll give you an example. So nakay sa knapsack bag. And this knapsack bag have a limit ka na weight limit bugaton sa isod. Let me kanang butang 2 kilograms or 2,000 grams ang pwede ra masoda ning baga. Let's say kanang para mo travel mo. So dapat na magdala mo kanang important things. Example, butang taog, laptops, tumbler, cellphone, or miskaon sa pana nga mag-matter sa iyang weight. So guys, ang mahitabo kung ang limit gani nga bag, ang weight limit gani nga bag is 2 kilograms o ma-exceed si jag 2 kilograms, ang mahitabo ngani mahitabo guys. Ngani magisi guys. Kay di kadaog ang weight o mula pa sa og 2 kilograms ang ibutang dari ang 2 kilograms pataas ang mabutang ng mga guys. So there's an example here na ay 200 grams phone, 500 grams na tumbler, 650 grams na books, 1000 grams na laptops, and 250 grams nga wallet. So guys, ug imo na siyang i-add tanan 200, 500 tapos 650 the 1,000 250 grams. So mulapas na siya 2,000 grams guys. So but pasabot dili na siya compatible diri na knapsack na imong kita. So magpili kanila o usa ka buta mga buta nga maigo ra sa 2,000 grams below 2 kilograms. So guys, so natay 5 ka items, the combination dila 32 tapos 0.3 seconds. Dila 10 ang combination 10 items din ang combination niya is 1024 and 0.807 milliseconds. So guys, so nakabantay mo guys, ang so on, mura siya ka ng bits bitaw, bits binary. Natada na 77 items takes 5 billion years for the computer to find an optimal solution. So what does this problem to do with genetic algorithm? The genetic algorithm can be used to generate a solution to a problem for which we have no way to calculate the solution. Genetic algorithms are a subgroup of evolutionary algorithm or evolutionary computing and they are used in self-learning machine learning algorithms and AI. They use the concept of the natural selection to simulate the survival of the fittest and the natural selection inside your computer. So, itong bug guys, example na to sila, knapsack problem. Example na sila na maigo sa genetic algorithm. What the best example guys para namo or para mas makasabot ba. So guys, na example dari ang usa ka knapsack na ay 10 items. Each of item have different weight. Natas na siya is iya nga grams, iyang kabugaton. So mura siya og nakabantay mo, mura siya ga binary case na 1010 1001 100101. So ang may items nga number 1 guys, mo na siya ang given nga number 1 mo na siya given nga nasud sa knapsack, mo na siya mga nasud. Ang 0 nga number mo na left on or dili wala gisulod sa bag. So guys, nata dari 10 knapsacks and kanang naka-include na po diri ang isang mga items na nakabantay mo na yung binary 0010 110 110. So ari ta magbase sa babaw karing mga items na napo kabuk guys sa mga iPhone, tumbler, books, laptops, wallet, headphone, pamaypay, notebook, perfume, tablet. So ingani siya guys. Og 001. So ari ta magbase sa 001. Ari ta magbase sa knapsack 1. Ano kinahanglan guys? 001 libro, wallet, headphone, notebook, and perfume. More na siya musod sa bagays. In the rest, wala siya gi-appeal kay di kadaog ang knapsack. Ang may tabo guys, og pasobraan nimo sa kilo, assurance kanihang ipakita, magisi siya. So, diri sa genetic, diri sa ang discussion nga genetic algorithm, og mo exceed sa 2,000 kilograms, ang result na is 0 guys. Okay? Ang maximum weight or ang maximum weight din sa knapsack is 2 kilogram ra na siya yung limit guys. So generation set of all current solution at a given point during the algorithm. Generation 0, starting generation and randomness of the possible solution. So guys, kaning knapsack 2 taman, knapsack 10 and so on, mora gyapon na siya guys. Muna atong basihan. More the best example para makagets, dali ra ta makagets. The natural selection. We use fitness function. Fitness then open and close parentheses to determine how good a solution is in our case. So guys, nata example diri ang fitness sa knapsack kuha na atong example gani ang ipakita, which is tumbler, phone, wallet, and laptop. So guys, gi-add siya tanan ang asang weight, isang grams, and na-equal siya og 1,950 grams. So, na-fit siya sa knapsack nga nag-exist og 2,000 grams. Sorry. So, returns the value of the pack items. as long as it is fits into the weight limit. Muna siya ang giingon ganina guys. So, diri na punta sa isa, fitness knapsack. Nag atong gibutang kita si laptop, si book, si tumbler. Datari ug imo nang i-add ilang grams. Ang grams sa laptop is 1,000. Ang book 650 plus 500 sa tumbler. So ang equals na guys ay 2,150. So guys, nilapas siya sa knapsack limit, weight limit guys, which is ang result is 0. Return 0 if the weight limit succeeds. Muna siya rules diri sa genetic algorithm. As you can see ganina guys, ang gipakita na example katong 10 knapsacks, mo ni siya result. Ganun guys, mo ni siya ni result. Now we select parent to the next generation solution. Mo ni siya result guys. Katong table number 1, katong na-appeal to, katong example ganiha is nag-result siya 775 grams. And so on, and then the knapsack number 7, 950, then knapsack number 8 is 0. Nganong 0 man? Kay daghan og 1, nilapas og 2,000 grams ang limit sa mga items na well packed. Okay guys, it randomly selects the parents width, but generally speaking, it'll most select the higher fitness score than really low ones. Nag-randomly select siya guys. Pinakabugat nga ay knapsack na nabutang nimo diri sa example guys, there is knapsack number 3 natay 1,950 grams. Mo siya kinadakan guys. Single point crossover function. Muna siya example guys sa items nga circlean diri sa 1,950 grams nga backpack number 3 and 950 backpack number 7. So, muna siya single point crossover function nato diri guys. So, ang fitness, muna siya binary number sa backpack number 3, 100, 110, then 0101. Then, ang knapsack number 7, which is the 950 grams, 001, 0101, 010. So, diri gibutang siya sa warag. Ang last 4 digits guys nga binary items is giswap sa backpack number 3. Ang last 4 binary numbers sa backpack number 3 giswap na pud siya sa number 7, backpack number 7, which is ang 0101 and 1010. So, kung nakasabot mo guys, giswap ang duha, muna siya gitawag og single point crossover function. So, ang fitness is 1,950 sa green bug and the yellow bug is 950. So, 2,000 is two new solution for the next generation. So we repeat this process until as long as we don't have enough specimen in the next generation. By crossing two solutions, we get something better ones from generation. So two generations, generally, this is how genetic algorithm works. However, it is governed by randomness. So there is no guarantee that you will sabotage the best solution, and that is the downside of the algorithm. So that's all guys, and thank you.